Hey, happy people, this is Mr. Wilcox. This is a quick look at our Piecewise Functions lesson. Remember, you can pause the video at any time or replay at any time, so I'm not really going to stop much. All right, so Piecewise Functions are functions that are composed of at least two functions, where each part applies to a different part of the domain. So in class, we're going to have either two parts or three parts, and they're going to tell us if something, and that if something is going to be the part of the domain that it's a part of. So let's look at this example. G of x. So g of x equals 4x minus 3 if x is greater than 3. So for all numbers bigger than 3, we're going to use the 4x minus 3. And g of x equals 5x plus 2 if x is less than or equal to 3. So 3 or smaller, we're going to use the 5x plus 2. So that means if we were trying to find g of negative 2, we got to figure out where negative 2 fits. Is negative 2 bigger than 3? No, it is not, so I'm not going to use 4x minus 3. Is negative 2 less than or equal to 3? Yes, it is, so I'm going to plug in negative 2 into the bottom function and simplify. So I'm going to get 5 times negative 2 is negative 10, plus 2 is negative 8. All right, how about g of 5? Is 5 bigger than 3? Yes, it is. So I'm going to use the top function. So I'm going to take my 4 times my 5 minus 3. So I'll get 20 minus 3, which is 17. So to evaluate a function that is a piecewise function, we first have to figure out which part of the domain the number in the parentheses is, and then plug it in. So again, we use the bottom equation for g of negative 2 because negative 2 is less than or equal to 3. And we used 4x minus 3 for g of 5 because 5 is bigger than 3. All right, so figure out if the number in parentheses belongs in which part of the domain, and then plug it in to that part of the function. All right, so graphing these. On the next slide, I'm going to get through get to the actual example, but here's what we're going to do graphically. We're going to look at each part of the graph individually, and we're going to put them on the same graph. So what that means, if we're given two parts, we're going to make two xy charts. If we're given three parts, we're going to make three xy charts, and we are going to put each part on the graph. So remember, if we have a less than or greater than, that means we're going to use open dots because that number is not part of the solution. So for example, if I put in negative 1 on top, that will not be part of the solution, but that is our endpoint. So we're going to put an open dot showing as not part of our solution. And less than or equal to or greater than or equal to, we're going to have a closed dot, meaning it is part of our solution. And remember, this is a function, so there's no spot in our graph where we can make a vertical line that goes through and touches more than one point, but it can touch both an open dot and a closed dot at the same time, because remember, an open dot is not a point. So what I mean by that is, let's do this actual example here. F of x equals x if x is less than or negative 1, x plus 1 if x is negative 1, less than or equal to x is less than or equal to 2, or negative 1 if x is greater than 2. So first equation is y equals x. When does that happen? Well, that happens if x is less than negative 1. So I'm going to put negative 1 in my xy chart and an open dot next to it, because I'm going to put an open dot at negative 1. And then I want numbers that are smaller than negative 1, so I'm going to put in negative 2 and negative 3. So if I put in negative 1 for x, y will be also equal to negative 1. If I put in negative 2 for x, I'll get negative 2. And if I put in negative 3 for x, for y, I get negative 3. All right. Second equation, we get y equals x plus 1. When do we have that? Well, if we have an endpoint of negative 1 and we're going to put a closed dot there, and we have a closed dot at -2. And remember, for an and inequality, that's a closed dot, we need a number in between. So a number in between -1 and 2 is 0. So if I plug in -1 into x, -1 plus 1, I get 0 out for y. If I put 0 in for x, 0 plus 1, I'm going to get 1 for y. If I put in a 2 for x, 2 plus 1 is 3, so I get a 3 for y. All right, and our last equation is y equals -1. And when do we have that? Well, we have that when x is greater than 2. So again, 2 is a endpoint. So I'm going to put an open dot there. So remember, even if it doesn't have an r equal to, we still need to put that as our endpoint, because we need to put an open dot there because 2.01 is bigger than 2. So we're going to show that point by connecting with a 0 with an open dot. And then I want numbers bigger than 2, so I'm going to choose 3 and 4. And my y is always going to be -1. So let's go through and graph each part on the graph and see what it looks like. So at -1, I have an open dot. -2, -2 is normal. -3 is normal. So it looks like I have a line going like that. All right. So I only have one direction, so it's going to go on forever until I get to -1, and then it can't be bigger than -1, so it's going to stop. Second part, it looks like I have -1, 0, and I have a closed dot there. All right, and then 0, 1 is normal, and 2, 3 is a closed dot. So it looks like we have this line. All right, so notice when we have two dimensions, or not, sorry, when we have two ends to our inequality, we have two ends to our graph. Here we had one end, so we only had one. And finally, we have our green line, y equals -1. It looks like at 2, -1, we have an open dot. At 3, -1, we're normal. 4, -1, so it looks like we have this horizontal line going this way. All right, so as horrible as this graph is, hopefully you can see that if we have one number in our inequality, we'll have an open or closed dot, and we'll have a line going off in one direction. If we have two, then our line stops in between those 2 points. And notice if I put a vertical line in any of these, if it goes through a closed, that's touching a dot. Remember, an open is not a dot, so this is still a function. All right, I have one more example for you. So we're going to do h of x equals -2 if x is less than 0, and 3 if x is between 0 and 5 and can be 0. So what we're going to do is we're going to make first our xy chart. So our first equation is y equals x. When do we have y equals x? Well, that's if x is less than 0. So make my xy chart. 0 is an endpoint. Since we are less than 0, I'm going to put an open dot there because 0 is not actually part of my solution, but it is an endpoint, so I have to put it in. I want to choose numbers that are less than 0 for this. So numbers that are less than 0 include -1, -2, and now let's plug some numbers in. So we have y is equal to x minus 2. So if I plug in 0 for x, 0 minus 2 is -2. If I plug in -1 for x, -1 minus 2 is -3 for y. And if I plug in -2, -2 minus 2 is -4. Right? For my second equation, I have y equals 3. When does this happen? Well, it happens when x is between 0 and 5. And we're going to choose a number in between, like 3. So for 0, I have a less than or equal to, so that means 0 is part of the solution, so that's a closed dot. And for 5, I have a less than, so that's an open dot. So now we have to go through and graph each graph. So at 0, -2, I have an open dot. At -1, -3, I have a normal dot, -2, -4. So I have a graph. I have a line. My line can't go through the open dot. It can only keep going in the negative direction because remember, our x's have to be smaller than 0. For my red portion, I have the dot 0. Oh, forgot to plug in. Sorry. All of my y's there are 3. So I have the point 0, 3. So I'm going to have a big closed dot there. All right. At 3, 3, I have a normal dot. And at 5, 5, or at 5, 3, 2, 3, 4, I have an open dot. So it looks like. Yeah. So again, if I have one number in my inequality, I'm going to have a line going off in one direction. So in this case, it's in the negative direction because we're less than. And if we have two parameters, so between 0 and 5, our line starts at 0 and ends at 5. All right, so your homework is a worksheet where I'm graphing piecewise function and plugging some in. Remember to check Brightspace for your assignment for tomorrow. I hope you have a great day, Cardinals, and I hope you make it count.